Ajit?
Yeah, it's audible. It's audible.
Yeah.
Vishal sir, please continue.
Vishal, please continue.
Hello,
Yeah, Vishal,
Ajit?
your voice is coming.
Yeah, yeah, we are. You, yeah, yeah.
No, it is audible.
Yeah, yeah.
Yeah. Okay. I start with introduction from mine. Okay. So I'm Vishal Yadav, working with the Cipla Limited, Kurkum, Pune, Unit 1, as a deputy manager for engineering, electrical, and instrumentation for both projects and maintenance. I have total more than 10 years of experience, and right now leading a section for both electrical and instrumentation. Okay.
Yeah.
So we start with the hazardous area classification. So what is exactly the hazardous area classification? Nowadays, it is very important, playing a role in chemical manufacturing as well as the API industries, where the solvents are being handled. So solvents are, we say, the chemical, different type of chemicals, and the different type of chemicals have their different properties, considering their flashing point, their characteristics, and their ignition point. Okay. So I will start with some introduction for the hazardous area classification. The hazardous classification is a method, okay, of analyzing and classifying the environment where explosion of gases atmosphere may occur. Okay, so it take into the account of ignition characteristics of gas or the chemical. Normally, the chemical terms we use a fume or the vapor. So the ignition energy, normally that ignition energy we refer as a gas group, and the ignition temperature, which contributing the main two factors on the hazardous or the flammable. So the ignition temperature is the temperature class that normally we are seeing on the any electrical and the instrumentation gadgets or the apparatus. On the nameplate, they mention the gas group or the temperature class. Okay. So main objective of this hazardous area classification is to study for proper selection of apparatus to be installed in the specified zone area. So now, what is the zone area? A zone area is the area where we can say the intensity of the chemical. The intensity of the chemical varies from the lower side to the higher side, and it is a very critical in terms. We refer in terms of critical. We refer the ignitions and this all. Okay. Normally the scope of this area is to identify and classify the hazardous atmosphere at manufacturing into the hazardous zone, and to specify the equipment with the specification for different zoning or the classing temperature, referring the temperature or the nature of the activity. Okay. So now in pharmaceutical industries, there are several multiple causes of fire and explosion. But inadequate electrical equipment, inappropriate electrical fixtures, improper electrical component design, substandard electrical installation in a major cause among the hazardous area classification. Okay, so this study is based on some standards. That standards are IS 5571, which normally describe the selection of electrical equipment which are installed or which are going to be installed. Okay, and IS 5572 for the hazardous area other than mines. So normally we are speaking on the chemical and the API industries. Okay, so the explosion of the gas atmosphere is detailed in the ISIEC 60079 clause 10. Right. So coming to the hazardous, there are the some zones. Normally the zones are described zone 0, zone 1 and zone 2. Okay. And again in zone 2 they are subdivided or sub-classified in the zone 21 and zone 22. So what is a zone 0? A zone 0 is a zone where the fumes or the chemical particles present continuously. If I want to give an example, you just consider a bottle of having some liquid. So inside area of that bottle is considered as a zone 0, where the fumes are enclosed in a fumes are closed condition in an enclosed area. Okay, and the fumes present, we can say a 24 into 7, or the extent where the material where the material is present. So coming to the zone 1 is the area where the fumes are present during the activity or during the operation. Okay, suppose if I want to give you the example, so the reactor is working and having a manufacturing batch. So during the manufacturing, whatever the fumes are generated, which are classified into zone 1 category. So coming to the zone 2, it is likely lower than the zone 1, where the fumes present only for the during the operation, but not more than a time. Okay. So if I give an example, so for maintenance activity, whenever we are removing any flange or any equipment, or removing the any top dish or any this one equipment part. So during for a specific time, the fumes are present or available there. So that is a zone 2. And coming to the zone 21 and zone 22. So they normally classified for the powder processing areas where the powders are being handled, or we can say the presence of the dust. So, so that is for zone 21 and zone 22. Okay. Ajit, please. So a source of or the vapor gas and the ventilation. So these two factors are affecting much on the hazardous area. Okay. So what is the source of release? So it is a point or a location where dust can be released or raised so that the explosion to the atmosphere can be found. Okay, means the formation of the, we can say the formation of the dust by which the explosion or the ignition may happen, the source of release. So the explosion may be due to the vapor or the gas. So it is not like every source of release produce explosion, but a small continuous source of release in this can produce hazardous layer. So their source of release are again classified like zone, like how the zones are classified now. Their source of release again classified into 3 types. Okay, so these are continuous, primary, and secondary. So what is a continuous? It is a dust cloud exists continuously for a longer or a shorter period. Okay, so again, primary release, release can be occur during operation. Okay, so if I want to give an example for the primary source of release, APD or the drying activity is going on and the bag cleaning or backfeeding, that comes into the primary source of release. The secondary source of release is not a continuous for a long period, but it is a short period. As I told, as a zone two. In the zone two, what happened during the maintenance activity or a smaller period of activity, the fumes are getting the films are available or present. So in the same way, if you consider in the secondary source of release, so the same way this it is not continuous for a longer period, but it is a short period. Okay. So coming to the ventilation, so ventilation plays a very important role to mitigate the zoning classification or the zoning area. So with having a proper ventilation system, so we can reduce zone 1 to the zone 2 and zone from zone 2 to the safe area. Okay. So if I brief how the ventilations are adequate for mitigating or reducing the zone area. So if the 12 air changes or more are maintained, then that area comes into the safe area. So normally we refer that service floor or electrical panels or the offices or the normally we use as a control room. Okay, and the gas mixture in the air it is less than 25% of LEL of continuous, then it is considered as adequate ventilation area. So what we have to maintain the percentage of LEL? It should be at least less than 25%. Okay, so this is about the ventilation system what we have or what we have to maintain and the source of the release. Okay, Ajit, next slide. Ajit. Hello. Just before to this side, one more thing is left. Okay, so type of electrical equipment or the identification of the electrical or instrumentation apparatus which are suitable for the hazardous installation or the hazardous area or zoning area installation. So normally if you see the any electrical equipment or instrument, you will find something on the nameplate that is EXD, EXD, 2A, 2B, 2C, like that. So if you see that detail of this exactly what the thing. So if you find the D, so D refer for the flame proof which is used or which is required the area where the continuous explosions are happening. Okay, and that is mainly suitable for all the zone area, that is zone 0, zone 1, zone 2. If you see the any of the apparatus or the instrument which is referred or written on E, so it is referred as an increased safety. Okay, so which do not allow the sparking of the component. If happens, then the arc will get quenched inside or the specified area only. So somewhere in some places you will find as a N. So N it indicates a non-sparking. Okay. So if you find I, so I it is referred as intrinsically safe, which is normally we use in terms or on the instrument. Okay, so right now we are going for the intrinsically safe or the ATEX approved instrument. Okay, so in this the voltage level is very low, so which is used to reduce the sparking and all. and if the area is zone 21 or the zone 22, that is powder processing area, then you will find P, alphabet P, and that is in there the positive pressure is maintained inside the component, which the intensity of the sparking of the ignition can be reduced. So if I conclude the hazardous area classification, this is mainly based on the chemical that which we are using, the property of the chemical that we are finding on MSDL, and their flashing point. Okay. So the IS 5572, what it say, the flashing point of any of the chemical which is less than 25. Okay. So that chemical and the chemical is being handled area is come into the hazardous area. So based on the lowest auto ignition point also, auto ignition point of the solvent, this classification is decided, and the severity of the ignition or the severity of the explosion that can be decided. Okay. So if I want to add something, so there are the temperature classes on the equipment or the instrument that normally you will find T1, T2, T3, T4, T5 till T6. So what is says the temperature of that particular equipment which can withstand the ignition temperature. So okay, if I start with a lower, so T6 is for the lower temperature. Again, these are the classified for the chemical, for the air, for the mining, and the many more such. We have the total this one, many this one. So this is about that. Okay, Ajit. So start with the HAZOP. So this is about the hazardous area classification. Hello.
Yeah, thank you. Thank you. Thank you. Hope I am audible to you all. And
Yes.
Mr. Vishalji, thank you for this presenting this beautiful webinar on hazardous area classification. And now, as per our planned webinar, we'll shift it to HAZOP definition and regulation. So I'm just requesting to our next presenter, Mr. Vijay Kumar and Mr. Sinrasu Sir, please take over this session. Thank you.
Yeah. Thank you, Suvantu. So once again, a warm good morning to all, and hope I'm audible. Yeah, I'm Vijay Kumar. So I have 17 years of experience in the field of environment, health, and safety. So currently, I'm associate with Syngene International, Bangalore as associate manager, environment, health, and safety. I'm not taking much time for the introduction, so let's go through the session. Before going there, so just I just want to know what is HAZOP study. The HAZOP study or the hazards appropriate study, and some cases we used to say as hazard analysis. So these are the one of the major process hazard analysis. For better understanding, simply we can say as hazards in process or hazards in operations. So what could be the probable hazards can develop and what can lead to the problem to the employees, equipment, process, and to the plant. So if you see the definition, it's a structural and a systematic technique for the system and examination of the risk management, and it is talking about the particularly um, about the planned design intention and what could be the deviation and can cause the effects or the major health effect to the people and to the environment. So this is also, we can say HERA, like in the form of HERA, like hazards identification and a risk assessment technique, which can be done before initiating any of the operation. And this is particularly a brainstorming technique. So generally you see a risk assessment or a job safety analysis or hazard and identification. So normal things, if you can see, it can be complied within a day. But a HAZOP study will takes even days together and even months together according to the process sequence and the um, length of the process. Okay, so and it's a qualitative technique. Okay, generally risk assessment, it's a quantitative technique. We can quantify the risk which is available in the process, and this HAZOP study, it's a qualitative technique, and it's an inductive risk assessment, we will say. Yes, and we have to study the from the bottom length of the particular detail with respect to the process. Okay, and if you see that background study of this HAZOP study, so when it was developing in the in the year of 1960s, in the British and in the worldwide, so many companies had the challenges, like even though they had the more and more effective systems and procedures and engineering controls, they were facing so many issues with respect to the plant operation, which resulted industrial accidents and incidents, which led a drain of the economy in the form of accidents, loss of property, and injury to the employees. So this was resulted. And in the year 1963, in the Imperial Chemical Industry of UK, so the safety advisor of the factory, so they started to decide a new development of the procedure or called critical evaluation or the critical examination. So that was the first seed which was laid to discover or to introduce the HAZOP study to the world. Second one, this particular HAZOP study, they were planning and they were particularly talking about the deviation which they observed from the process. And then they converted these critical examination into operability studies, and then it is converted into HAZOP study. And in the earlier stage, the HAZOP study was particularly intended for the plants which is having the continuous operations like petroleum industries and oil and gas, pesticides, etc. And in this study, this particular study was introduced in the imperial chemical industry, the heavy organic chemical division, and this study was directly applied to the phenol manufacturing plant. And this study was introduced by Mr. Trevor Klutz. Okay, he was a factory safety advisor for imperial chemical industry. Okay, and later they started introducing and they are using for the bulk productions, API, mining industries, and wherever they are having the potential usage of discontinuous operations and everything. The purpose of the HAZOP study, if you see, the HAZOP study is to investigate how the system or the plant deviates from the design intention and creating a risk to the personal equipment and for the process. And in the procedure, if you see in the HAZOP study, it is a multidisciplinary team people will be involving to start the study, and including the external team people in the form of subject matter experts, consultants, safety auditors, and internal teams like process team, process engineering team, and they are particularly discussing particularly about this subject in the form of a brainstorming session, and they were giving the recommendation with respect to the plant modification. And when and where we have to do this HAZOP study in the sense, so this HAZOP study has to be performed for the newly constructed plants or the structurally modified plants with respect to MOC or the new installation or the modified system, everything. and for a new processes. For example, your plan might be old, and you are going to develop a new product called A or B or something called X, Y, Z, whatever might be. So that cases, before starting this process, we have to conduct this as of study. Okay, and even after this study, if there is any change in the process, or if any change in the equipment, or any change in the design, we should conduct the HAZOP study, and the HAZOP inputs and the outcomes to be communicated to the all the team members. Okay, so here the HAZOP study, before you know what is a hazard. So hazard is anything that can give the harm to the people, material, equipment, and to the plant, and even to the environment. Okay, and risk, generally the risk mean it is something called as a combination of the probability of occurrence of harm to the severity to the harm. So generally we will say as likelihood or the probability into the consequence. The probability, the probability in the sense what could be the frequency of this incident going to be, like whether it's on the daily regular routine shift basis, or in once in a week, or once in a month, or once in a year, or once in the 10 years, something according to the frequency. And the consequence in the sense, that what could be the outcome from the deviation in the time of in terms of accidents or the incidents, like a first aid injury, or equipment breakage, or a major injury, or a dangerous occurrence in the form of structural collapse, or something like a damage to the major part of this plant. So these are the things to be considering the risk or the risk assessment. Okay, so when we are planning the HACCP methodology, so you can see that first one, we should plan a particular process sequence, and we should call for a particular team for the HACCP study, and team should define the what could be the probable things can be identified in the HACCP study, and what is the existing safeguards in the form of existing controls, and what could be the recommendations, and followed by what are the things to be done. Okay, so in this case, so first one, we should form a HACCP team. So the HACCP team comprises of, so first one, a chairperson or the facilitator. So it can be a process engineering team person or the AHS person. His responsibility is to coordinate to conduct the HACCP study. So he will call the team members for the study, and he will arrange the meetings, the venues, locations, everything, and he will be act as a coordinator. Second one, a secretary. So secretary is the person, he is a person who has to do the clerical jobs. Clerical jobs mean whatever the discussed points in the brainstorming techniques or in the discussion points has to be noted in the form of a specified written document procedure or a records. So he has to write. And apart from that, the team members should be the process engineering team people, and the production or the operating team people, subject matter experts, stores who have been part of the material handling, followed by the instrumentation engineer and general mechanical engineers, quality control, quality assurance, EHS, and for the potent drug handling or something like the oncology drugs wherever we are manufacturing. So that cases, even the environment team who has been part of this effluent treatment also to be added in the ASAP study team to get their inputs. Okay, and then in this case, always what we will be doing, mean we will take the study sequence of this process, like what are the sequence of process in the form of node. The node in the sense a particular steps of the process. For example, charging a material to a process equipment, or adding some chemical, or the flow of the material to the reactor. So this is something called as we will say as a node. Okay, so in this case we have to add, take all the study nodes or the process sequence for the study, and in this we have to apply the parameters or the guide words. So guide words, I mean, these are some set of vocabularies which will give some meanings and it has to be applied for each sequence. Okay, so in this case, what we have to do, we should divide the system into parts that I told you in the form of nodes and select the part of the defined intention or the planned modified area, then identify the deviation using the guide words. The guide words in the sense we have some general, we will use 7 guide words called no, more, less, as well as, part of, reverse, and other than. So no mean the negation of intention. So the no mean no flow. For example, there is no flow and what could be the impact? And more flow. So for example, the design says it should be something we have to add in the form of a controlled addition, like 1 liter per minute or 1 liter per second. So in that case, if the flow is going more than that, what could be the impact? And lesser than. So it's something like the quantitative decreasing. So for example, you meant to charge something like 10 liter of solvent or 200 liter of solvent to the process. So in this case, 180 liter was charged to the process equipment. What could be the probable reason of that minimum quantity charging and what could be the outcome? And more than in the sense, suppose if there is more quantity of solvent charge, for example, as I want to say, if they want to charge 15 liter of so called compound called X, and instead of 15 liter, there were something like 20 liter of chemical called charge. So what could be the outcome and what is the possible causes of the deviation? Okay, and as well as means, for example, I can say if you want to charge a material called A, or something we can say you want to charge a solvent called toluene. Okay, you want to charge the toluene, but along with the toluene some methanol also being entered or something like we can say is in the due to the cross contamination the water entered along with the solvent. So that cases what could be the probable impact to the process as well as to the facility. Then reverse. So reverse mean it is an complete logic opposition to the intention. So for example, instead of charging, instead of flow, there is no flow. Instead of heating, if it is something goes like chilling. Okay. So these are something what could be the probable. And these are the general guide words used for the process. Other than that, 4 guide words like early, late, before, and after. These are the special guide words being used for the continuous processing industry. So the early or the late stage, it is related to the clock time, and the before or after these things which is related to the order or the sequence of the process. For example, as per the process sequence, first one they want to charge the material called A and they have to do the heating and followed by chilling and the workup, then they have to do the filtration. So if something goes in the vice versa or something they have done in the mixed manner, or that instead of starting a process A, they have done something B, that comes, it is called as before or after something we will be saying. Okay, and to conduct a process or the HAZOP study, we need some of the background documents. So first one, for initiating any process, the retrospective lab development record. Okay, the like we know that any new product development, it will be having in the discovery phase study. The discovery phase study in the sense, so the scientific community they will do the process in a scale like something in gram or milligram for the process, and they will be developing according to the chemical formula and the structural with respect to the process. And that detail should be there because they had the positive and negative study. For example, they are confirmed that this process in the initial stage of reaction to be heated in the max of 80 degree. Okay, there they may be concluded in the process study, and in the same well they will be performing the study for 90, 100 and 200 according to, and they will do that in the lower stage. So what particular case this process is attaining its requirement, and at what stage this chemical is started decomposing, that things also they will be adding the part of this lab discovery study. That document has to be there. Second one, we should have the process flow diagram. The process flow mean you have to know from where it is starting and where it is ending, and the piping and instrumentation diagram. Okay, So what are the utility connections and the solvent lines, whatever might be, which is supporting to the process or which is associated to the part of the study, that has to be taken into the consideration for the study. And list of chemicals. For example, if it is a chemical industry or anything, for example, if an engine, anything like a petroleum industry also, the what could be the process, equipments, and what is the sequence that has to be captured, and the chemicals, the quantity, the state, and the nature of chemical, whether it is a corrosive or whether it is a flammable or it's an oxidizer or an explosive or something, it can be like a toxic in nature. So those things to be taken in the consideration. And the general plan layout, what is a layout, like the equipment, how it is installed, for example, second floor, first floor, third floor, whatever, everything, and where it is start from and where it is ending, that detail has to be there. And relieving and the vending system. So relieving in the sense, what is the general vending procedure they are given. Some cases, the generally the plan might be designed for 3 bar pressure, and this particular process, some cases this normal operating pressure might be 5 or 6. So that cases, whether this equipment have the adequate capacity to handle this operation or something, even if the pressure goes more than 1 bar, so there can be some particular risk to the operation. So that cases, what is the changes required with respect to the equipment design, that has to be taken. Okay. And other than that, the operating and maintenance procedure in the form of preventive maintenance or the AMC, and the safety operating procedure, generally we will say as SOP, and the preventive maintenance details. And finally, we need to know the emergency response procedure and the people involved in the process. Okay, these are to be captured in the form of study. Okay, so then this technique they will apply, and these techniques generally what they will do, they will design that in a particular area like a conference room or the outside the factory, because it should not have any disturbance from the public. Okay, so this, because it's required each everyone's knowledge and expectation from the particular study, and the inputs will be collectively discussed in a brainstorming session. Okay, in this study, each intention, for example, process safety team, they will give their input and their experience, and the engineering team, they can give this particular equipment, what could be the design procedure and what are the safest features we have, everything to be captured. And then finally, we have to conclude in the form of documentation. So generally, as I told you, we should take it in the form of a defined checklist or a defined format. So we will have the serial number and the guidelines, what we have to be taken, and the element or the study node. As we told, I want to charge a chemical called A to the process. And what could be the probable deviation with respect to the design intention. Okay, and what could be the probable causes. For example, here we have taken, so as I told you want to charge a solvent to a reactor, or you have to charge a material. You simply take a, you want to charge some, you want to pump water to from one tank to another. Okay, so that cases, if the flow is not attained, what could be the problem? Okay, what could be the problem? Resulted, there is no flow. So you can say something like there is a power failure in the system, or something like the pump pipeline was not connected, or the footwall or the impeller failure, or there is no power supply to the system, or the motor failure. Anything can be captured in the system, or somewhere the pipeline having leakage, which was the pumping is started, but this totally the system is going on. Okay, and in this case, what could be the probable consequences? For example, you can say you are pumping water from the underground tank of a ground to the third floor. In between there is no water pumping, so what could be the problem to the operation or to the system? Even there might be no water for cooking, or you can say something, no water for their cloth washing, anything you can take. And after that, existing safe controls, we have to discuss the existing safe control. The existing safe control in the sense, that like what are the things. For example, that you can say it is a particular pipeline, and it leak testing we have conducted after the installation, like 1.5 times of operating pressure as per the factories act. So we have done it, so that can be considered. Second one, you can say, so if the pump is failed, it can give some alarm, or if the level is not there, it will give some alarm, or if the level is there, it can give the indication, or in the time of SMS to the people. So anything we can say that, or something like a fail-safe mode, or like if before that process sequence, as per the automation process, it will have a pre-check like pump condition, leakage, pressure, and the level in the tank, everything as per the sequence. And if it is not there, the pump will not start or the system will get tripped off. So that can be the design phase in the, improvements with respect to the engineering controls. And apart from that, what are the things to be captured? Like even though we have this much control, if this particular recommendation we have added, so it can be a value addition to improvise the process and to increase the efficiency. So like, so you can give like, for example, that pumping system, like the level indicator somewhere, or the level switch can be in the area where that particular operating device or the switch is there. Okay, so that can, if you given, so the people, when even though system fails, so what can be done by the particular person who is going to switch on the particular pump or the system, so he can know whether the level is there or the level is not there, mean he can, we have to top up the tank and then he can start the pumping. So these are the things. And you know, whatever the 7 guide words we told, we have to apply for each deplanned deviations. Like I told about flow. So flow in the sense, for the flow we have to apply the no flow, more flow, less flow, and a part of as well as, and the reverse. So everything we have to apply, and what could be the probable causes and what could be the probable consequences with respect to the recommendation we have to give, and we have to define the responsibility to someone. Here we have given something like charging something like a material like detergents. So you don't think about this one. I can give something like a cleaning agent or a soap solution, whatever might be. Okay, so like if there is no flow of this detergent, so what will be the thing? Either the tank might be leakage or something like the particular detergent level was not there, and technician was not selection of the pumps also there. Some cases even the industry, what is happening, like their pump might be wrongly coded. Instead of the pump A, they might be given in the called as B, so which is leading some issues. That has to be captured. And other than, as I told you, all the sequence so far, you have 20 steps in the process, 20 steps to be taken in the form of study node, and the intention of the study to be captured, and what could be the probable deviation, and the probable deviation, what could be the consequences, and the existing control, and the existing control in the senses. Again, we have to study the what could be the recommendation, and what could be the additional features to be added, what could be the timeline to come by this particular observation. That things we have to capture with respect to the study. And then we have to see, for example, 20 in the sense, 20 into 7, 140 steps we have to do, and the 140 steps you might get some particular things. So everything to be captured in the study. And before applying this thing, we have to do the equipment mapping or the process flow detail. We have to have a physical verification. This physical verification, how they will do mean, before initiating the process, the all team member of the HAZOP study will be going to the particular planned area of the process, and they will perform a PSSR, pre-startup safety review. Okay, because some of the things might be given in the form of theoretical nature, and finally when we are going to have a particular study with respect to the thing, there might be some discrepancies, like this equipment might not be matching to the requirement, or something like that pressure or the design of this equipment might not be adequate to take care of this process with respect to the higher pressure operation or the MOC. Some cases we might have a only a glass-line reactor, or something we can say a particular equipment, the MOC, like general SS reactor, like SS 316, STM, L grade, something like. So suppose if you need to have some acidic reactions, we need to have a HASTLI or the all glass reactor, whatever might be. So everything to be captured in the things, and they will have a pre-assessment in the form of pre-startup safety review before they are doing the study. Okay, and the compliances, everything as per the discussion, we should have a documentation. The documentation in the sense, if you have the in-house HAZOP study procedure, as per the company internal procedure, you can document and you can make it in the form of note. Then HAZOP communication. The HAZOP communication in the sense, what we have to do. So what we have discussed, we should communicate to the people who are involving for the process. Okay, who are the people fight me? So fight me, for example, the dispensing area might be in the stores department or in the warehouse. What are the particular relevant points to the stores? We have to communicate and we have to ensure the compliance with respect to. It can be a training, or it can be equipment, or it can be additional features as per the recommendation. Then to the people who are being for the process, like a production or for the engineering team, everything to be assessed, and the healthiness of the equipment or the design features like the pressure relief valves, preventive maintenance of the equipment, everything to be checked and everything to be captured. And finally, when they are initiating the first few process, for example, we discussed for a process called A, and we plan to have the process of A in 40 batches. So initially, we should observe the inputs and the effectiveness of the HAZOP study. Whether the first one, whether this process is carried out as per the defined recommendation which is captured in the HAZOP format. Second one, whether the HAZOP study, whatever the recommendation versus compliance, it is occurred and it is attained according to the requirement. Third one, what are the hidden hazards which is observed from the process? It might be that during the process, which is not described in the HAZOP study, something like even though this line was connected and the pumping because of the non-capacity pump, like the pump capacity, like something like something not done. So in the capacity of the pump or any issues, whatever we observed versus the document versus the actual in the plan, we have to capture and we have to discuss and we have to take the corrective and preventive actions. According to the corrective and preventive actions, we should do some modification in the document. Again, we have to take the recommendation and we should ensure the compliance. And after that, if required any change in the process, or if required any change in the equipment, or if required any change in the material, or any change in the quantity, anything, everything to be captured, and we should conduct a training and the HAZOP communication to all the people who are being part of this particular process. Okay, these are the things to be done with respect to, okay, this to be done. So this is about the general outline about the HAZOP study. And particular to the HAZOP study, if you see what could be the problems, it having some advantages and disadvantages too. So first one, the advantages, if you say, it can particularly talk about the major hazards associated with the human error as well as to the probable consequences to the manpower or the employees. Second one, all the sequence of the process can be captured in the HAZOP study, like the hazards with respect to human and hazards with respect to the equipment, system, everything. Third one, it is not something like a one person is giving a particular statement that we can do this methodology. So it's not a single person decision is captured. It is a brainstorming technology. The brainstorming technology in the sense, so it's going to be a bigger debate or the argument, healthy argument, and all the outcome from the arguments are again filtered with respect to the process, which is adequate and which is necessary to the process, and it is captured in the particular process, and that is captured in the recommendation. So that is taken. Again, this is a systematic and comprehensive methodology, and more and simple intention purpose, everything will be captured. Okay, so this is the thing. And the second one, if you see, it is having some disadvantages also. So it's having some negativity as well also. The first one, it's required a major time consuming process. Okay, and some cases, for example, you might be called a person called your section head of this engineering. So due to another meeting, he might send his representative to the particular meeting for the HAZOP study. And if he is not technically sound with respect to the equipment and the process, and there we cannot get some proper output from the further which is required for the process. Secondly, even the team members not having a proper information with respect to the process, even it can going to be another headache, like in the form of hazards. Third one, it's required the people presence, like everyone should be in the time, and calling and coordinating the team people, it's going to be a challenging one. Next one, if you see, um, like what we have to see, the like something like, if you see the HAZOP study, and some cases what will be happening mean, even the backup documents like the process hazard analysis, generally for the chemical industries, it's required DSC study, differential scanning calorimetry, for the decomposition temperature, reaction calorimetry, which is related to the utility requirement, and something like the powder safety data study, like fall hammer test, something which is related to the minimum ignition energy. So some cases, even some industries are not having this particularly related to the no backup documents. So that cases, even with respect to the existing document, this HAZOP is not going to be effective. And major thing, this is a qualitative techniques and not a quantitative techniques. You cannot quantify the level or the quantity of risk which is available, or the which is existing with respect to the process. And nowadays, but if you see, and some industries are following some different way of the risk HAZOP study. So that means they are conducting the HAZOP study with a risk assessment for the qualitative and the quantitative methodology. The qualitative in the sense, the general, what are the things to be captured, and quantitative in the sense, what is the risk level. Risk level being mean, this mean the risk assessment matrix, like what is the likelihood level or the probability, and what it could be the consequences, and they will be considering the risk level, and the risk level to be considered in the low, medium, and the high. If and the recommendation what we give with respect to the particular study or the hazard analysis, and after that this risk level should be brought into the low risk or the residual risk level. Okay, so that things also, even some of the advanced industries are following, and we too follow the same methodology. That means the qualitative with the quantitative methodology, so we can quantify, and whatever the recommendation we have given, whether it is effective with respect to the particular study of the process. Okay, this is about the HAZOP study. So generally it's a dry subject. I know that even when I was in the beginning stage of this HAZOP duty, I struggled a lot with respect to understanding the thing. And whenever we are interacting or we are planning to study, you take a small node, small sequence of a process, like a small step, like a filtration, or a reaction, or a scrubber system, or a new pump. So like symbol by symbol, we can study on that, and then we can compile the all document, because you cannot sit in one day to complete the HAZOP study. Even I had and personally experienced that even for a particular process, we sat for 30 days in a particular area for conducting one single HAZOP study. So the major problem, it is a time consuming process, but outcome will be very effective to prevent the industrial occurrences like the industrial incidents. Okay, so this is about the HAZOP study. I just hand over this session to Suvendu. So this is about the session. So thank you guys for your valuable time to listening to this session. Thank you. Suvantu? Suvantu, I would think you are in mute.
Yeah, am I able to hear? Am I
Yeah,
audible?
yeah, yeah. Yeah, you are audible. Yeah.
Yeah, so I'd like to thank all the wonderful people who spoke today and performed in this webinar, and also I thankful to those backend team who make this webinar happen. I think it is really a nice webinar because we got to know a lot of things regarding hazardous area classification and HAZOP and why it is important. So it's the time for Q&A. If any doubt, please type in chat box, or please unmute yourself and please ask questions. Our presenter will try to catch up all the questions.
Suvantu, Vijay Kumar here. I have few things to explain with respect to the hazardous area classification. Generally,
Yeah,
the
please go
first,
ahead, sir.
yeah, yeah. Sorry, I'm not overlapping to our Vishal. So just I'm giving some knowledge what I am aware of that. So first one, you should know the area, whether it's hazardous or non-hazardous. So hazardous in the sense, first one, whether we have usage of flammables, or the flammable in the form of liquid, or in the form of vapor, or in the form of powder, and what is the usage frequency, or what is whether it is a storage, or whether it is a processing area, or in the next to the area. So then which location which is falling under the zone 0 or zone 1 or zone 2. Second one, whether it's zone 20 or 21, 22. So that things we have to see. After that, we should know whether these electrical equipment, so this is particularly talking about the electrical equipments with respect to safety, which can act as an ignition source in the form of short circuit, or improper cabling, or failure of earthing, anything. So in these cases, what are the suitable electrical fixtures we have to add? So in this case, again, we should know few things. One is what are the flame-proof classification, whether it's a EXD, EXI, EXE, or EXP, or EXN. Second one, we should know the gas grouping. So generally, 1A, 1B, 2A, 2B, 2C. So these are the two gas groupings. And with respect to if this particular facility have the usage of hydrogen or acetylene, so that cases definitely the picture should comply the 2C requirements. And then the next one is a temperature classification. Temperature classification, why it is required? I mean, it is particularly talking about the maximum surface temperature which can be attained for the continuous operation of the equipment, particularly from the motor or from the motor equipment devices. For example, you can say in the continuous process equipments, for a process, this agitator will be running for 48 hours or 78 hours according to the process equivalent. So that cases, the maximum surface temperature can be changed from equipment to equipment according to the temperature classification. So like what we can say is like if it is a normal equipment, the surface temperature can go more than that of the auto ignition temperature, and that cases it can be very, very dangerous. And if any vapor, for example, generally you are charging a material called methanol. So methanol boiling point is 68, but you generally water, we can say water boiling point is 100. So that means you cannot you heat the water more than 100 degree. If you heat the water, maximum it will go 100 to 101 or 102. But same thing for solvents. Methanol, the boiling point is 68. But how these particular solvent getting is auto ignition temperature? The auto ignition temperature for methanol is 435 degree. The 435 degree, how it will attend mean this particular solvent in the form of vapor, when it is coming to contact to the motor, which is already in the temperature range of 430, 450, 460. So it is getting its auto ignition temperature, and it is fair enough to lead the ignition. Okay, so that case is how you have to decide the temperature classification mean either T1, T2, 3, 4, T5, T6. So here you should know lesser the T value will have the higher hazard and the higher the T value will have the lesser hazard. So for example, here the safest motor is T6. Okay, in this case, T6 is that maximum surface temperature can be 85 degree, and T5 mean maximum surface temperature can be 100 degree, and T5 4 mean 135, and T3 200, and T2 mean it is 300, and T1 mean it is 430 degree. So this is a maximum temperature classification with respect to the temperature. And in this case, which one is suitable? You should take the chemicals which we are using for the process. For example, you have 10 chemical which is having the lowest auto ignition temperature. Generally, you know, mostly the industries will follow hexane. The hexane having the auto ignition temperature of 210. So in this case, we have to take the 80% of the auto ignition value. So auto ignition in the sense 80% in the sense you have to take 160. So with respect to the 160 degree of this auto ignition temperature, which is the nearest classified motor. So that case is T4 motor. So T4 motor is fair enough to handle this operation. So that means because even though this hexane required 210 degree as an auto ignition temperature to get the fire, but the motor at any cost it will never go beyond 135 degrees, so we are safer. And next one, IP, ingress protection. The protection IP mean ingress protection. The first it will be a two number in the form of numerical count. The first value it is particularly discussing about the powder protection. The second value is particularly talking about the protection towards water in the form of jet length or in the form of immersion or mist or spray, anything. So the maximum protection will be 68, 68, 6 for the maximum for powder and 8 is the maximum for water. So if you have the 68 type motor, it is more safe. And how will you come to know this attestation? Like Vishal told, that motor will have a stamping like EXT or something. And one more thing, this will have some approval body. One is PESO, Petroleum Explosives and Safety Organization, which is from Nagpur, or it is given in the called CCOE number, Chief Controller of Explosives. That number will be mentioned in the plate, or else it will have the stamping of CMRI, Central Mine Research Institute. That approval number will be mentioned. So that things to be used for. So we have to see EX, the particular classification, and what is a gas grouping according to the usage. Third one, the temperature. Fourth one, the IP rating. So four things will be captured in the thing. And particularly the EXT is a common thing for motor, and EXI, intrinsically safer, it is particularly for your automated system and automation, your PLC, your controller, your system, everything. Automated equipments, everything will have. And you know, EXE, that is an increased safety. Increased safety means the non-flame proof fixture is installed in an FLP enclosure. For example, your CCTV, you are installing a CCTV in an FLP fixture, that is called increased safety. Okay, and even though you have an FLP equipment, the integrity has to be maintained always when we are operating or when we are installing the equipment. The integrity like Allen screws, internal gaskets, glanding, dummy, and your earthing internally and externally, everything to be in a proper way. Even though, for example, your motor or your fixture having a 4 Allen screws in the power terminal, and out of 4, if one screw is missing, the integrity is gone. So that cases that FLP, even though the particular motor is mentioned as FLP, this motor is going to act as a non-FLP. So ensuring the integrity of equipment is also really more important with respect to the flame proof fixture, with respect to fire prevention. And you know, flame proof in the sense, it will either not allow the fire from the external sources, and it will never allow the fire from internal short circuit to enter to the outside. So it is like a, like what we will say, like waterproof, same type of setup. Clear? So this is about my, I just want to convey my knowledge to people. Thank you.
Thank you, sir. Thank you. And Vijay sir,
Thank you,
once
sir.
again, I come to you because I got a questions from Mr. Mohan that in HAZOP, by creating teams, how many members? It is any defined pattern or what?
Um, Members, generally minimum three. Three in the sense it is not something like restricted. You can have more people. Some of the companies, what they will do, right? They will call the consultant, like the safety expert who is in the form of auditing everything. And apart from that, definitely the few people. One is the process safety engineering team. If you don't have the process safety engineering team, your HS team should be there to take care of these things. Again, your stores team, because stores team will be the handling dispensing of chemicals. Again, operator level and your process team. Process team means who is going to do the production activity, and the supporting team like your maintenance or the engineering team in the form of instrumentation, and your mechanical team, electrical team, followed by your quality control team, because they will have their in process check and final TRF everything. This team should be minimum for the study. Okay, more than that you can have more people. Like if you want to see something like each team, you can have one more person. Like that also are two persons who is already having some, because two people mean two people will not going to have the same knowledge. So each different experience from the different domain, they can give better feedback with respect to the HAZOP study.
Okay, one more question I got. I will come to all of my presenters, all of our presenter, that any protocols we are following, like root cause analysis or any document we are following by maintaining hazardous classification and HAZOP study. I got this question from Mr. Mahesh.
Um, Hazardous area classification general, this one as per the attacks approval. Other than that, industries they will have, because whenever we are constructing a plant in the form of flammable and anything you are using, then definitely we should have the zone classification. Even your operating facility or your lab or your um, process plant should have the zone classification. So in the layout, it should be defined which are the area comes under zone 1, and which are the area comes under zone 2, and which are the area comes under zone 3. So that has to be, sorry, zone 2. So these are the things first to be captured. And the companies, they are not following any fixed document. They are customizing the document according to their standards. Like as I told you, right, even the initial stage in my experience, we were using the simple HAZOP study format. That means serial number, what is a study node, then what is a deviation, causes of deviation, what is the consequences, existing control, additional recommendation, followed by the responsibility. But nowadays, even some companies, they are following with the FMEA, failure mode effective analysis. Some people, they are following the HERA, hazards identification and risk assessment. That means they are, as I told you, the risk level, like consequences, probability in the risk rating, and finally after the recommendation and ensuring the compliance, what is the risk rating. That points also they are adding with respect to the HAZOP study. So it is not restricted to have, you have to follow this particular format, but minimum you should have these things like deviation, causes of deviation, your parameter or the guide wire should be there, and your existing control, additional control, recommendation. These are the things to be captured in the HAZOP study.
Okay, thank you. And I'm having one more questions from Mr. Hari sir. Uh, what type of wall is considered between zone 0 and zone 1?
See, the wall in the sense, generally it should be a airproof door. Like some of the area, what they will do, they will form the air curtain. Some cases, what they will do, they will have some airlock doors. Okay, like you are have the changeover ante room or the changeover entry room. So particular thing, if that area like the zone 1 have any leakage, immediately it should not enter to the zone 2 area. So to prevent that, what they will do, they will have some interlock, like the corridor will be maintained with positive pressure. The internal area will be generally how it will be mean the zone 0. So zone 0 in the common example, I can say, if you say a petrol bulk, The petrol bulk in the sense the petrol tank, it comes under zone 0. That means it is having continuous presence of flammable vapor. Okay, and the filling point, you are the particular service person who is filling the petrol, that area comes under zone 1, and the surrounding area next to the area it comes under zone 2. And for industry, what they will do, zone 2 fixtures also comes under FLP. But what they will do as much as possible, how to minimize the vapor or the flammable mixture entry from the one zoning to another, it is best. And as per some of the standards, it is recommended to have the 2 hours rated panel or the 2 hours rated door. How they will mean? Generally the civil walls having the 2 hours fire rating. Other than that, we have some like this Rockwell insulated panel, it is also having 2 hours fire rated, and even view panel having some 2 hours particular fire rating. Other than that, PAR panel, polyisocyanurate, nowadays we can get, because that is a fire resistant material, because even we are introducing to our cold room panel, it's a constructant. This particular material, it is not a normal puff material, it will never catch. So that type of panel also can act as. And if you have the normal doors, at least you should have the FLP air curtain to prevent the air. And as an engineering control, if you are maintaining the hazardous workplace with negative pressure, and the other zoning with the positive pressure, will prevent the entry of this flammable mixture from one zone to another area.
Yeah, thank you. And I think it's the time for wrapping up. We'll expect one few more questions. If it is there, that will be here. Else we'll wrap up this webinar. We'll wait for next 2 minutes. If any doubt, kindly please type on chat box. And I think we should cover with all good topics today's, and it will clarify our doubts regarding hazardous area classifications and HAZOP. So I am once again thank you all for joining this webinar and make this event successful. I always thankful to my presenters, 3 presenters who conducted today, who taken this webinar, and really thankful. And once again, Ajit, I am thankful for you also. So Vijay sir, Sinrasu sir, and Vishal ji, I think we'll wrap up this webinar. Thank you once again, and we'll further look ahead to be with you for another topic for our colleagues. Thank you once again all.
Thank you guys.